So briefly, what are we talking about? What is Apache Spark? So like it says here, it's a general purpose. It's a general purpose engine for large-scale data processing. What does that mean? Well, it means, first of all, the origins of Spark date back to 2003, when Google released a paper called MapReduce for large-scale data processing, and it was about their solution to how to index the entire internet and then build a highly performant search engine on top of it. And as a result of that very influential paper, the first iteration of an open source project called Hadoop came around, and it was donated to the Apache Software Foundation. And it worked well for a while until hardware got cheaper. First of all, Hadoop was entirely disk-based, so it would crawl the entire internet and use a series of map and reduce operations, which you probably know from functional programming. So it used a series of map and reduce operations to take that data in a raw format and successively refine it until to the point where it was really easily and really performantly queryable, so that Google could offer you really performant search engine. Back then, memory was very expensive. In the meantime, memory got cheaper, and the next generation data processing engine after Hadoop is this project we are talking today about, and it runs really quickly. It allows to process really large amounts of data relatively quickly, and you can see here that they conducted a benchmark of how fast Spark would run the same workload as Hadoop, and it blows Hadoop out of the water because it runs in memory. So basically, the core idea of Spark is that if you have a small business and your entire data is 300 gigabytes of information, well, what you can do is buy 10 servers with 64 gigabytes of memory each, and then distribute your entire data across those 10 servers, and still have 300 gigabytes more space, because you need another 300 of gigabytes of memory to store a copy of your data, and that's because Spark relies on immutability to do processing. So first of all, you have your raw data, and then a map gets applied to your raw data, and then that's going to generate another transformed copy of your data, and then it goes back and forth. So you need twice the memory in your entire cluster to run your processing. So as I was showing you before, Spark nowadays Spark relies on the notion of data frames, which goes back to the statistical programming language R, and it was adapted in the form of the pandas library in the Python programming language. And it's the idea that you can treat your data in memory as a rectangular data structure, just like you would a spreadsheet. Only it's a spreadsheet that's distributed across 10 servers, 100 servers, however many servers you have available. It supports SQL as a query language. It also has a module for streaming. So basically, I'm going to demo today a streaming application based on Apache Spark and the streaming processor called Kafka. There's a module for machine learning, for distributed machine learning, and it contains pretty much every machine learning algorithm that's distributable. The one exception is KNN, K nearest neighbors, which is not supported by Spark, and it also contains a module. Inside of the standard distribution, it contains a module for graph processing called GraphX. Just out of curiosity, how many people here have been in this morning's keynote? Okay, a fair number. So I'm going to show you some code, and I'm going to, like I said, I'm going to give the demo of that Spark streaming application, and I'm going to ask you guys at some point to have your smartphones and laptops ready, because well, I'm going to need you to generate some data for the Spark streaming application. Cool. So having said that, let me demo the first thing I wanted to show you today. So I'm going to show you some code and explain what I'm doing in an environment that behaves like a REPL, and it's called a notebook. How many people here have have encountered the notion of a notebook in Python and in R? Just a few. So the idea of a notebook is that there's a standard browser-based interface that you type code into, and then you press Control Enter or Shift Enter, and that code gets sent to some sort of server as it is, gets executed on the server, and then the result gets sent back to you and displayed below the code cell. So the first thing I'm going to explain to you is how Spark evolved, how the Spark API evolved. It used to be the case a few releases ago that you needed to work based on the so-called RDD interface. And RDD stands for Resilient Distributed Data Set. And it was basically pretending that you have a Scala collection, and that instead of the collection fitting in the memory of one server, it only fits in the memory of 10 servers. So if you have if you have a terabyte of information and you have 1,000 servers, you can pretend that you work on a single collection using the functional transformation primitives, but the results, those closures or those lambda functions get sent out to each one of the servers by the central node, get where the data is. The transformation happens on each one of those nodes, and the results stay there until you need some sort of aggregated, very small set of data. And that's basic operation idea of Spark. RDDs have nowadays, since Spark version 2.0, they have become kind of deprecated, and the new API that most people work with is data frames. And there's also data sets, the API called data sets, which is available only in Scala. And it's the idea of bringing the strong type safety of Scala into the world of data frames. So having said that, let's first start with understanding how to, if we have a very basic data set, input data set, how would we create a Spark data frame on top based on this particular data set. And so I'm going to do as I said. I'm going to execute the code in this notebook, and this is what our data looks like. So what I'm going to do at some point is I'm going to do a basic group by, but you need to understand that whenever I do group by on this particular data set, grouping by A and B, and computing the totals on the right-hand side, this operation doesn't happen on my on the driver program, it's called. So the data gets spread out, the computation gets spread out, and then the computation happens on each one of the nodes. And so, you can, if you have 1 million records and 1,000 servers, then each node gets 1,000 servers to process. That's our input data set. And by the way, you probably guessed the language I'm using is Scala. Spark, Apache Spark is written in Scala. So what I'm doing now is just splitting the input data set by carriage return, and then verifying that I have what I need to have. It's the first record in my data set, B, comma 9. So what I'm next going to do, what Spark requires when you work with it in the Scala programming language, it requires you to define a case class. And the case class, think of a case class as the schema for our data set. So I need to, Scala needs to understand and Spark needs to understand that it is the first thing I'm importing into it is a string, and then the second thing is an integer. So that's why I need a case class. So I'm basically defining a schema right now. So I'm defining I have defined the case class, and I'm defining how to parse the record. So what I'm basically saying, once you have one of those individual rows, take what is on the left-hand side and what is on the right-hand side, cast the right-hand side to integer, and then put those two things in a tuple, and it's the the data record is kind of a tuple type structure. So once I have that, what I can do now is, so here's where we're getting into the actual Spark API. So based on data that I do have in memory, I'm going to create a data frame. And I'm going to give it a Lambda function. So this Lambda function, so this is the function we saw before. And I'm placing an underscore here, meaning that whatever is the argument, I don't care about the argument, because I'm thinking of this function as a Lambda function. So I could even do this. So put the underscore separately here. So I'm going to create a data frame. And once I create the data frame, you can tell that the type of the data structure is data frame from the Apache Spark SQL package. And right now I'm going to cast it into a data set, which, as I said, is a strongly typed, compile time type safe version of a data frame. So let's have a look at what we have right now. So we have a data set, and it looks like this. Okay, so at some point it's going to show me. This is what it is. It looks like a result set from an SQL statement. And this is exactly what I'm going to treat it like, because this is how the data frame of / DataSet API in Spark was designed to work. So remember from this morning's keynote, he used this create or replace temp view, and his temp view was T.A.K.E. And the data frame or data set that he was working with, so he was working in Python, and Python doesn't have data sets, but he called the create or replace temp view on his data frame. And what this is, what's here inside of these quotes is something that I can now refer to from my SQL statements as a table. So it's not a table that's backed by a real disk storage like in a relational database, but I can treat it as a table in my work with the Spark API. So we are going to look exactly how that works. So remember, we have the table called raw data, and I can now issue this select statement against that table. And I'm going to delete the show from here. And let's see how this looks like. Um, so, right, okay, so I forgot to execute this one. Okay, and now again this one. So it's thinking, okay, and this is what I expected, right? And think about how this would be the aggregated result from a petabyte of information, and it's exactly the same thing. You pretend you work locally, but you work in a cluster. So I'm going to assign this to a variable, and then I'm going to issue another SQL statement just to make sure that we are on the same page, and look at the result. So I'm going to. So it works just as you would expect it to work, and I have a cheat sheet. So I promised you it would be a live coding session, and I don't have this yet in the notebook, but I have a cheat sheet somewhere, and I'm going to copy paste from that cheat sheet and show you something very cool. So it's in here somewhere. It's wait a second. So row number. DataSet. Okay. No, this it's not the moment yet. So right, this is going to come a little later. So what I can do now is save my work in a temporary place for later reuse, and this temporary place where I can store data temporarily is a small version of a Hive data warehouse. How many people here know about Hive? Okay, one person, two people. So Spark has a really tight integration with Hive, and all the data frames and the data set metadata is actually stored in a small place called the Hive Metastore. So that's what powers the data frame and the DataSet API. So what I'm going to do here is save the filtered data frame into a Hive table called filtered data. And then if I want to retrieve it again, I can just say, give me that table based on the Spark session. By the way, Spark session here is the entry point for all my Spark activities. So whenever I need to initiate a new Spark data pipeline, I'm going to start with the Spark session. There's a catalog underlying all of this, and we can have a look at what the catalog looks like. So I can list the tables, and we saw that the raw data is memory backed. That's why the table type is temporary here. And we saved the filtered data in a Hive table, and it's going to show up as managed in the catalog. The next thing I'm going to talk about is user-defined functions. So for those of you who went yesterday to the BigQuery talk, this is you remember how Martin talked about the user-defined functions in JavaScript. Well, in Spark, the user-defined functions are going to be in whatever language you are currently using. So I'm going to define a function in Scala, and then I'm going to reuse that function. I'm going to register the Scala function with Spark, and then I'm going to pretend that that function is actually an SQL function, and uh, call call that function on a column just like I would otherwise. So I'm going to define a function that what it does is it uppercases its input and then it surrounds it with square brackets. So this is the Scala definition of the function, and right now the time has come to register it, and I'm going to register it, and that's the point where it becomes known to the Spark SQL engine. And what I can do now is I can say select, and this function I just defined here of a column, apply to column, and then the results are going to show up like this. Oh yeah, still need to show it. So this is what I expected, and this is the time has come to show you that neat trick with windowing functions. So Spark SQL is SQL 2003 compliant, and this data frame after UDF data frame, I'm going to create a new Spark SQL table on top of it. Okay, and I'm going to run a slightly more sophisticated SQL statement, which makes use of something called row number. And let's see first, before we talk about it, let's see what it looks like. So it goes out and does its thing, and it returns to me. So what did I do in this SQL statement? So first of all, I partitioned my data set by whatever this key is, so this artificial key. So you can see that it grouped the A's and the B's together. I ordered each one of the partitions by the value in descending order, so you can see here. And then I numbered the rows in each partition, 1, 2, 3, 4, 1, 2, 3, 4. So if you remember from yesterday's BigQuery talk, he was talking about how you would only do append only. So Spark and Spark streaming allow you to build a new kind of data warehouse, which some people call a time-stamped streaming data warehouse, or whatever. So the idea is that the last write wins. That's why you only append data to the front of the stream, and you only care about whatever the most recent data was inserted. So the way you do this, and Martin explained this yesterday, and I'm not sure how clear that was. So the way you do this is by ordering that continuous stream of data by timestamp descending, and then putting a row number on each one of the rows, and then you only care about row number equals 1. So that's how you start to think about big data in this context. All right, so I have a few more examples. So just to show that I can reuse anything from the Java ecosystems, I'm going to generate and register a function that generates a UUID, and put that UUID to the left of of my data set. So this is what it looks like. So I can, so right now I can do whatever. So if you have a database that's or this you could use this as a partition key for Kafka or as the partition key for Cassandra in case you want to spread your load evenly. So the next thing I'm going to do is show how to. I have a few data sets here which contain geographical data, and I'm going to join them together. So I have cities that the data set looks like this. City ID. No, this is sorry. This is city ID. Yeah. So this is city ID. This is country ID, and then city name. So just like I did before, I'm going to define the case classes, aka schemas. Well, so the thing about case classes is they are Scala's somewhat they are Scala's way of defining data modeling primitive. So in Scala you have these algebraic data types that I'm not going to go into, but essentially you have product types and you have sum types, and this particular one is a product type because it's a tuple of three things. And oh yeah, so I'm reusing it the case class for Spark for my purposes here. What I now have is yeah, so I'm looking at the country's data set. So I have a country ID, continent ID, and country name. So they're this thing here. And let's see what else. So the country's header is this, and then I define the case class for the country. And this is where it gets interesting. So usually you'd have to, before you start working with Spark, you'd have to, first of all, define the case class, and then define this thing again. So in order to not repeat yourself, there's this thing in Spark called encoders, which is going to acknowledge that you have a product type called described by a case class called city, and it's going to, based on that case class, it's going to derive the schema from that particular case class, and so that makes things a lot more readable and dry. Okay, so I define the schemas, and right now what I do is, so I'm going to, based on the city schema, I'm going to use the Spark's data source API to read this CSV file, and Spark has built-in integration for CSV and another format called new line separated JSON, among other things. So this is for text stuff. So I'm now reading the CSV file, and I'm moving it into a data set which says that this thing is now compile time type safe, like we discussed before. So what I'm doing next is doing the same thing for countries, and the time has come to do the select, and this is what it looks like. So it's basically ingesting the CSV, ingesting the data in the form of data frames or data sets, and then registering the tables called stamp views, and then running SQL just like you would normally. Okay, let's see what else we have. So because this was the purpose of this was for a workshop, I also have an exercise, but I'm now going to go into the Spark streaming demo, if you guys are fine with this. So before we do this, let me start. I already have prepared something here. So D0, okay, D1. So I'm now running a Spark streaming job. And what this application is going to do is there's a web endpoint, and that web endpoint contains something like this. Let's see, let's go back in here. So the web endpoint, okay. So the web endpoint looks like this. And I'm going to ask you to play around with this in a minute. Just don't do it right now. Let me do it first. So I'm now going to click one time on triple B, and then watch what happens in this particular screen. So click, and let's see what happens here. So I made this application to showcase streaming analytics, which is to say, show me for a given time window of 30 seconds. The time window, so the time windows is 30 seconds in length, and it's a tumbling window like Simon was describing in the keynote, and or was it Romeo? So the idea is that there's a 30-second time window that moves by 5 seconds into the future every 5 seconds. So what you can see here is that my single click on the button triple B was registered 6 times because there are six such microsegments. So once that click has expired out of the window, I'm no longer reading anything into the Spark streaming application. So what I'm going to ask you to do now is go into, so everybody's connected with the hotel Wi-Fi. So if you are connected with the hotel Wi-Fi, please go to this URL and start clicking randomly on various buttons so that we can see what happens in the result window. And I think this is going to be all, because I'm the only thing standing between you guys and lunch. All right, 5 minutes, cool. So no takers. Are you guys on the hotel Wi-Fi? Let me check again. So yes, 10.03.144.9999. Yep, that's the one. You need to be on the hotel Wi-Fi though. Radisson guest, correct? Yeah. It doesn't. All right. Well, say again. So it's the port is 9999. 4 nines, yes. So this is again the port. It would be a pity. Yeah, this usually works with other audiences, but right. Okay. So I'm going to do it for you just before we finish. So I'm going to randomly click here on various things and click, 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 click. I'm clicking randomly, and what we can see here is that, first of all, I have a section of code that um, tallies up all the clicks, all the individual clicks, and you see at some point I clicked on some buttons more than once, like 5 times D. And then it does some slicing and dicing like you would in a normal BI application. It slices by what the letter is that repeats itself, and how long the string is. So that's the essence of streaming analytics with Spark Streaming, and I think I'm out of time, right? So questions? Question? No, let me show you. I already have something for you. So the notebook is here. So if you go to this URL, is.gd/sparknb, as in Spark Notebook, it's going to redirect you to let's see here, the not no wait, give me a second. So it's going to redirect you here. So my GitHub account and repository Docker Spark Notebook. There's a Docker command here for those of you who know how to use Docker. So the notebook is entirely Docker based, and if you run this command, it's going to start a version of a Play framework called Spark Notebook, and then you're going to be able to connect to a local host port 28888, and then it's that this is interface is going to show up. So something like this, and you just click on Spark Basics. Other questions? Question? So HDFS is supported. S3 is supported. So obviously text files, CVS, and new line separated JSON. There are also connectors. So this is what Spark supports by default. There are also third-party connectors for Cassandra, HBase, Redshift, Yak, anything you can think of that's widely used in the big data space. There's a connector between Spark and that thing.